For this investigation, I will walk through a safe ransomware readiness lab. I'm using a Windows virtual machine, Sysmon, Splunk, and fake company files to simulate ransomware-like behavior in a controlled way. The goal is to safely test detection, investigation, and recovery steps. This lab does not use real ransomware, real malware, or real encryption. I'm using NAT during setup and Splunk work so I can access tools and troubleshoot more easily. After the suspicious activity is confirmed, I'm switching the virtual machine to host-only networking for containment. These snapshots are learning checkpoints. I should have taken them during each phase, but I created them afterward for clarity in this video. This NAT snapshot represents the investigation setup. Now I'm showing the Fake Company folder. The folder is called Fake Company, and it contains test departments like finance, HR, legal, sales, and executive. These are fake files only, and they are used for the simulation. Next, I'm verifying that Sysmon is running. Sysmon helps collect detailed endpoint logs, including process creation and file creation events. This is important because I need those logs to investigate the ransomware-like activity. Now I'm checking Event Viewer. I'm going to the Sysmon operational log to confirm that Sysmon is collecting events. Here I can see events such as process creation, network connection, and file creation activity. I'm searching for Sysmon event IDs 1, 11, and 3 because they show the main activity I want to investigate. Event ID 1 shows process creation, Event ID 11 shows file creation, and Event ID 3 shows network connections. Together, these help connect the suspicious PowerShell activity, file changes, and possible network behavior. Now I'm checking Splunk. I'm running a basic search against the ransomware-like index. This search returns events, which confirms that Splunk is receiving data from the virtual machine. Now I'm filtering specifically for Sysmon logs in Splunk. This confirms that Sysmon events are searchable in the ransomware-like index. This is important because I will use these logs to investigate the suspicious behavior later. Now I am running the safe ransomware-like simulation. The script only affects files inside the fake company folder. This is done only to generate telemetry for detection and investigation. Now I'm checking the fake company folder for .locked files. The results show that multiple fake files were renamed with the .locked extension. This confirms that the simulation created ransomware-like file impact. Next, I'm counting the number of .locked files. This gives me a clear number to use as endpoint impact evidence. The result shows 500, which confirms that the safe simulation impacted 500 fake business files inside the fake company folder. Now I'm checking for fake ransom notes. The results show readme restore files.txt files and multiple fake company folders. Now moving back into Splunk for detection. First, I'm counting Sysmon event code 11 events, which represent file creation activity. This gives me a high-level view of how much file activity was captured. Next, I'm looking at file activity over time. This is one of the strongest detections because ransom-like behavior usually creates a sudden spike in file changes. Most of the timeline shows low activity, but there is one major spike around June 24th. Now I'm searching for encoded PowerShell. The result shows PowerShell.exe running with the encoded command flag. Encoded PowerShell can be suspicious because it may hide what a command is doing. In this lab, it is safe, but it is still realistic detection behavior. Here I found PowerShell.exe using encoded command. That is suspicious because encoded PowerShell can hide the real command. Again, in this lab, it's safe, but in a real investigation, I would treat this as suspicious activity. Next, I'm checking whether PowerShell is connected to file activity. PowerShell is a legitimate Windows tool, but it becomes suspicious when it appears with encoded commands and bulk file changes. This helps connect the PowerShell activity to the ransomware-like file behavior. Here I found PowerShell connected to file creation activity. One PowerShell path shows 3 file events, and another shows 11 file events. By itself, this is not enough to prove ransomware, but when I combine it with the encoded PowerShell command, the file activity spike, and the .locked files, it supports the ransomware-like behavior. Now I'm reviewing the top file creating processes. This helps me separate normal system activity from suspicious activity. Some events may come from Windows or Splunk processes, so I'm looking at the full pattern instead of only one event. Here I'm reviewing the top file creating processes. Some results are normal Windows activity, but PowerShell also appears. This is why I look at the full pattern, the spike, encoded PowerShell, and the .lock files. Now I'm building a PowerShell-focused timeline. This timeline helps me see when PowerShell runs and what events happen around it. It helps connect process activity, command line activity, and file activity during the investigation. Together, these findings support the ransomware-like activity. Next, I'm summarizing the activity by host, user, and process. This helps answer important investigation questions. I can see which host is involved, which user appears in the logs, and which PowerShell process is connected to the activity. This shows the Windows virtual machine, the user, and PowerShell activity. This helps me narrow down where the suspicious behavior happened. Finally, I'm creating a short incident summary in Splunk. This summarizes the total events, users, and processes involved. At this point, the suspicious behavior is supported by the file spike, PowerShell activity, encoded command usage, .locked files, and fake ransom notes. Now I'm creating an investigation timeline. The timeline shows when the PowerShell activity happened. The summary shows the host, users, and process involved. This gives me the main details before containment and recovery. Now that I've finished my Splunk investigation, I'm moving into the response phase. The first action I'm going to take is containment, which means stopping the affected machine from communicating with anything else. This host-only snapshot represents containment. I'm switching my virtual machine from NAT to host-only networking. This simulates isolating an affected endpoint before recovery. Before recovery, I'm preserving evidence. I'm creating the temp folder to store my evidence. Then I'm exporting the .locked file list and ransom note locations into text files before recovery. After preserving the evidence, the next step is to understand the scope of the incident. Instead of only saying files were affected, I want to show which folders and departments were impacted. The results show each fake company department had 100 impacted files. This helps show the blast radius of the simulated ransomware activity. Now that I've contained the machine, preserved evidence, and confirmed the scope, I can move into recovery. The goal is to return the system to a known good clean state. First, I'm restoring the fake files by removing the .locked extension, deleting the fake ransom notes, and verifying that the system was clean afterward. First, I want to confirm that the simulated impact is still present. There are 500 .locked files and fake ransom notes inside the fake company folders. Now I'm performing controlled manual recovery. The script restores the file names by removing the .locked extension and removes the fake ransom notes from the fake company folders. Now I'm confirming a clean recovery. It looks like the recovery was successful. The .locked file count is 0, and the fake ransom notes are no longer present. I'm running get service Sysmon 64 to confirm that Sysmon is still running after recovery. This proves that endpoint monitoring is still active while I validate the system. This final snapshot represents the clean system after recovery. I'm also checking Splunk to confirm there are no suspicious PowerShell file events after recovery. For the post-recovery Splunk check, I set the time range to start after recovery, around 9:06 p.m. on July 1st. There were 0 matching PowerShell file creation events, which supports that the simulated activity stopped. Now I'm mapping the lab activity to MitraTac. I map the activity to PowerShell, obfuscated files or information, file and directory discovery, and data encrypted for impact. PowerShell execution maps to T1059.001. Obfuscated files or information maps to T1027 because the command used encoded PowerShell. File and directory discovery maps to T1083 because the simulation searched through the fake company folders. And data encrypted for impact maps to T1486 as simulated ransomware-like impact because the files were renamed with .locked, but no real encryption happened. Next, I'm looking at possible false positives. A high number of file events could come from Windows updates, backups, or OneDrive sync. Not every alert means ransomware. Some file activity can come from normal tools like updates, backups, or OneDrive. To reduce noise, I would combine multiple signals instead of relying on one event. I would look at the process, file path, user, timing, encoded PowerShell, and ransom-like artifacts together.